Hi, I'm Ray Chen from University of Houston. Welcome to our ICCV paper, Workie-Talkie, Accelerating Federal Learning by Overlapping Computing and Communication while Contrastive Regularization. Federal learning is a promising distributed learning paradigm that allows mobile devices to jointly train a unified global model without sharing their private datasets. However, practical development of FL over mobile device is very challenging due to huge training latency. Conventional methods with interleaved local training and model updates suffer from high network latency even after the straggler devices are removed. Alternatively, this work focuses on overlapping implementations that bury communications into the local training. Such schemes are more robust to high network latency and hence effectively speed up the federated training. In the overlapping scheme, mobile devices keep local training while sending the model updates to the FL server. Hence, when the global model is received, the local models have been updated for extra S steps. Such model state inconsistency is also known as model stillness issue in overlapping schemes. It causes model divergence and could slow down the training process. Existing works consider gradient correction to replace the still model information to mitigate divergence issue. However, such gradient correction have three major limitations. First, they suffer from accuracy degradation while high network latency and data heterogeneity coexist. Second, the state-of-art scheme has large memory requirement when network latency is high, which is not very mobile-friendly. Last but not the least, they require the same model architecture for all devices. It limits the model architecture design, which heavily depending on the capability of low-end device in the FL system. Instead, we consider a contrastive regularizar to guide the local training. By leveraging the idea from contrastive learning, the regularizar will enforce local model to learn closer to positive samples, which is the global model in our case. Hence, we can mitigate divergent issues automatically. The preliminary study on CIFAR-10 dataset has validated that using contrastive regularizar has better performance in improving model similarity than using gradient correction schemes. Hence, we propose our overlapping FL scheme named FedCR, which consists of two major components. One is class-wise contrastive regularizar, and the other is heterogeneous subnetwork training. To introduce contrastive regularizar into local objective, we consider a fixed projector to learn feature alignment between local and global models, and insert it before the linear classifiers. In the contrastive regularization design, we treat the global model as the positive sample and the local model from the last round as the negative sample. Besides, FedCR considered to dynamically adjust the temperature parameter locally based on both global model performance and the local data distribution to improve the feature alignment. It's worth noting that FedCR uses a fixed projector to map the feature representation of an arbitrary input shape into a fixed dimension. Thus, our proposed scheme do not require devices to keep the same model architecture. Mobile devices can select a NIST order subnetwork to fit their hardware and reduce the computing overhead. The experiment on CIFAR 100 shows that FedCR can maintain high testing accuracy of global model under the heterogeneous model training compared with the peer scheme. In our experiment, we compared FedCR with two state-of-art synchronized FL schemes that tackle high network latency. From the figures, we can observe that FedCR outperformed the two peer schemes in terms of accelerating training time under three different image datasets. Thank you for your listening.